The goal of this lesson is to introduce you to networking concepts related to IoT. By the end of this lesson, you will understand the importance of network connectivity in IoT devices and will successfully establish a Wi-Fi connection. In this lesson, we will be moving deeper into the world of IoT by exploring how to connect the ESP32 microcontroller to a Wi-Fi network. One of the defining characteristics of IoT devices is their ability to send and receive data over the internet, allowing them for remote monitoring, control, and data analysis. Establishing a Wi-Fi connection is the first step in enabling your IoT device to interact with the outside world. This allows our ESP32 to send sensor data to cloud platforms, trigger alerts, or even host web servers that you can access via your browser on any device connected on the same network. Wi-Fi connectivity is a key feature in many IoT devices. It provides a means to wirelessly communicate data over very long distances without the need for physical connections. By connecting your ESP to your local Wi-Fi network, you can communicate with web servers, send data to cloud services, receive commands remotely, and serve web pages that display real-time data. These capabilities are what makes IoT so powerful, allowing for remote data monitoring, device control, and of course, automation. So, before we dive into the code, you will need the following information. You will need your network credentials, the SSID or network name and password of your Wi-Fi network. Make sure you have access to a reliable Wi-Fi network with internet access. Ensure that your Arduino IDE is updated and that the Wi-Fi H library is included. The ESP32 Wi-Fi library is critical as it provides all of the necessary functions to connect to a Wi-Fi network. Connecting the ESP32 to Wi-Fi is relatively straightforward. Let's go through the basic code structure for establishing a Wi-Fi connection. So I'm gonna start with a blank template. First of all, we need to include our Wi-Fi library. Then we need to input Wi-Fi network credentials. And this will be a constant character SSID, and this will be your SSID or the Wi-Fi network name. And after that we also create another constant for the password. Great, now that we have created all of our variables, it is time to get into the setup. First of all, we want to start the serial.begin function. This will be used to troubleshoot the code and see where the connection was unsuccessful or successful. And we're going to be 115, 200 as per usual. Do not forget the semicolon up here as well. Now let's add a little delay just to make sure that everything has been initialized before we move forward. This should be around 1/10 of a second. Do not forget to document your code. Now we're going to be using the Wi-Fi.begin function. And it's going to have the SSID and the password that we previously inputted up here. Of course, in here you have to input your own credentials and of course document it. Amazing. Now let's see if the connection was successful by printing it out on the serial monitor. Serial print, and let's say connecting to Wi-Fi. Great. Now let's add a small delay so that we can wait until the ESP32 successfully connects to Wi-Fi. While Wi-Fi.status is not equal to connected, we will have it that it delays for 1 second. Prints 1 dot. This will make it so that if the connection is unsuccessful, it will print 1 dot every second. This will make it so the user can understand that the Wi-Fi connection is being attempted but is yet to be successful. Now that we have created a clause for waiting for the connection, let's start with a feedback from the ESP. we will actually print the IP address of the ESP. Serial.print ln is going to be empty. This would just create an empty line.
Then we have serial.print.
Another new line connected to Wi-Fi to let us know that the connection is successful with an exclamation mark because we are excited like that about the Wi-Fi connectivity. And then we will be inputting the serial print. Without a new line, we will have the IP address. Remember to include the space. And now we will have the actual IP address. It's serial.print ln, of course, because we're starting a new line. And it's gonna be Wi-Fi dot local IP, and that's it. Let's document it. Print the IP address associated with the ESP32. This is going to be the IP address given on your local network, so no security problems in that. The loop will remain empty because we only want to initialize the Wi-Fi. Let's upload it, and while we wait for it to upload, we will explain the code. We include the Wi-Fi.h library, which provides the function for connecting the Wi-Fi networks. The SSID and password variables store the name and password of your Wi-Fi net. You will need to replace the your Wi-Fi and your password with your actual network information. Then the Wi-Fi.begin function initiates the connection to the Wi-Fi network using the provided credentials. The while Wi-Fi status loop checks the connection status and keep retrying until the ESP32 successfully connects to the Wi-Fi network. Once connected, the ESP32 will display its IP address using Wi-Fi.local IP. The address allows you to communicate with the ESP32 over your local network. So, to ensure that your ESP32 has successfully connected to the Wi-Fi network, you can monitor the output in the serial monitor. First, you need to upload the code by using the upload button, and then you need to open the serial monitor. This can either be done with Ctrl-Shift-M or going up here in the right topmost corner. Make sure that the baud rate of the serial monitor is set to 115/200 to match the code. Now that it is done uploading, let's check the serial monitor. If you do not have an output, remember you can press the reset button on the right of your ESP32 board. The serial monitor will display the connection status. You should see dots appearing every second as the ESP32 attempts to connect to the Wi-Fi network. Mine already connected, so there were no dots to print out. Once the connection is successful, it will print connected to Wi-Fi, followed by the ESP32's local address. Some troubleshooting tips. Double check that your SSID and password are correct. Incorrect credentials will prevent the ESP32 from connecting. Make sure that your ESP32 is within range of the Wi-Fi network. If the signal is weak, it may struggle to connect. Also, some networks may have security features that prevent new devices from connecting. If you are unable to connect, try using a different Wi-Fi network or consult your network administrator. Once connected, the ESP32 becomes a part of your local network. This allows it to communicate with other devices on the same network, send data to cloud platforms, or host web servers. In upcoming lessons, we will be building on this by hosting a simple web server on the ESP32. This will serve real-time sensor data that you can access from any web browser within the same network. So, in this lesson, we have covered the basics of Wi-Fi connectivity in IoT devices, and we have successfully connected the ESP32 to your local Wi-Fi. This is a critical step in every IoT project, as it enables the device to interact with the internet and other networked devices. Now that we have connected the ESP32 to the network, it's time to take it to the next step, serving a web page from the ESP32. In the next lesson, we will be diving into the creation of a simple web server that will, of course, display real-time sensor data. By mastering Wi-Fi connectivity, you have unlocked a powerful feature of the ESP32. This opens the door to remote monitoring, data transmission, and interactive web applications. Great job! I forgot to input my actual credentials. Interesting. That's crazy. Anyways,